Good morning, dear students. I am Sanjay sir, your physics teacher. I want to welcome you all in my third day virtual class. I will discuss physics part of science book. There are altogether 6 chapters in physics. We are continuing our course from chapter 4, that is gravity and gravitation. We are near the end of the chapter. Previously, we have completed 2 sessions. So today is the third day. Today, we are going to complete the theoretical portion of the chapter. After this, we will discuss about the solving of numerical problems in the next class. Before starting the third day session of the chapter, I must thank you all for your active participation in the classes. It is good to see that many of you have submitted your assignments, but till now, some of you haven't submitted it. That's disappointing. So please submit it on time. And please try to involve your all other friends in the classes in the day to come. Now, let's begin the session with our difference. That is the difference between gravity and acceleration due to gravity. In the previous class, we have discussed about gravity and acceleration due to gravity. Gravity is the force exerted by any heavenly body on an object. The earth pulls the object near to it towards its center. You all are well known. If there are any object, we feel weight because of gravity. The pulling force of the earth is called Earth's gravity. Similarly, when an object is dropped from certain height, it falls down with a velocity. The velocity goes on increasing, causing acceleration to it. The acceleration thus produced in the object in the absence of any reactional force is the acceleration due to gravity. The acceleration produced in a freely falling object, obviously that is shown, is the acceleration due to gravity. Gravity is a force, and so its unit should be same as that of force. And the unit of gravity, as the unit of force is Newton, so unit of gravity is also Newton. Similarly, acceleration due to gravity is acceleration, and so its unit should be same as acceleration. That is, the unit of acceleration is meter per second squared. So the unit of acceleration due to gravity should be is also meter per second squared. You can write some other differences. Okay. Now, moving towards the next topic, that is acceleration due to gravity is independent upon mass of an object. Experimentally, we have learned this in the feather coin experiment. And this mathematical proof is given by well-known scientist Newton, Sir Isaac Newton. So now Newton, let's see the figure. let's draw a figure. Here, the circle represents a spherical object. And let's place another object, small object, on its surface. So obviously, this heavenly body pulls that object towards its center. In comparison to the size of the heavenly body, the size of object is negligible. Its radius is negligible, and that's why the radius of heavenly body is the distance between the heavenly body and the object. The distance is r. Mass of heavenly body, capital M, and that of mass of object, small m. Okay, so as there are two objects, heavenly body and object, and so there is the force of attraction, that is the gravitational force of attraction. And so gravitational force, that F is, you know that is gmm by d square. Here, sorry, gm1 m2 by d square. Here, m1 mass of an object, m2 mass of another object. We are considering m1 as mass of heavenly body, m2 mass of a small object, and the distance between them. So in place of m1 we can write capital M. In place of m2 we can write small m. In place of d we can write r, and the expression will be like this. Let's assume it as equation 1. From Newton's second law of motion, we have learned that force is equal to ma. So a is the acceleration. Here mg, g is acceleration, but here the g is called acceleration due to gravity. Let's assume this equation as equation 2. If we combine 1 and 2, we'll get mg equals to, or gmm by r square equals to mg, the same. So just writing opposite for our convenience. So m and m will cancel each other and leaving g equals to gm by r square. If you see here in this formula, there is no small m. It means there is no mass of object. So acceleration due to gravity does not depend upon mass of an object. But acceleration due to gravity is inversely proportional to square of radius. How can we prove? For that, as you know, capital G, that is universal constant or universal gravitational constant, simply gravitational constant. Value is same everywhere throughout the whole universe. Capital M, mass of heavenly body, which remains same. For a particular heavenly body, it won't change due to its shape, but the radius may be different. For example, for the Earth, polar radius is less, equatorial radius is more. So for the same Earth having same mass, radius is different. So due to different radius, due to different place, G will change, but G and M for particular heavenly body remains same. So let's tell its value as, let's suppose its value as K. So the expression will be in our mind G equals to K by R square. If you remember in the previous classes, when we have to change proportionality sign into equality, we use equal and a constant. Conversely, to write a equality sign in terms of proportionality sign, we require equal to and a constant, and for that, in that case, only we can write proportional sign. So then it becomes T proportional to 1 by R square, or we can say G inversely proportional to square of radius. This is the proof of that acceleration due to gravity is inversely proportional to square of radius of the heavenly body. Acceleration due to gravity on the surface of the Earth. If you see in the figure, or as you know, the Earth is not perfect spherical in shape. It is flattened at the poles and bulged at the equator. So its polar radius is less than the equatorial radius. The acceleration due to gravity is inversely proportional to the square of radius, and where the radius is less, the acceleration due to gravity is more. Where the radius is more, acceleration due to gravity is less. So the value of g, or acceleration due to gravity, is more at the poles than the equator, because pole pole has less radius in comparison to equator. So hence an object reaches to the surface of the pole faster than the equator when dropped from same height. It tells us that as the acceleration due to gravity is more at the pole, it means acceleration is more at the pole. So velocity of the falling object is more at the pole, and so the object falls faster at the pole. In the same way, equator, the value of acceleration due to gravity is less, so acceleration is less. As acceleration is less, there is less change in velocity, and that's why the object falls slowly at the equator. It should be noted that there is no relation between mass of an object and acceleration due to gravity that we have learned theoretically, we have experimentally, so everywhere. So the same acceleration is produced on different objects dropping at the same place at the same height. From the same height. Okay. Now, acceleration due to gravity at height. Here h is written in subscript. H is for height. G is the acceleration due to gravity. So let's see the figure. Here, the Earth having mass capital M, radius capital R, an object is at height h from the surface of the Earth that has mass M, small m. Distance between them, the mass of heavenly body from the center of the heavenly body to the center of the object is d, and that is r plus h, because okay, r plus h. Let's leave it. You all understand this. So now, if we write in the form of formula of gravitational force, there are two masses, capital M, small m, distance between the r plus h, and so g m1 m2 by d square becomes g mm by d r plus h whole square. Okay, g mm by r plus h whole square. And if we remove m and m, gh will be gm by r plus h whole square. Okay, now if you see the figure, acceleration due to gravity depends on, you can say, two factors. Acceleration due to gravity at height depends on three factors, that are mass of heavenly body, because in the formula here it's capital M, capital R, and H. So mass of the heavenly body, radius of the heavenly body, or height or depth of the object from the surface of heavenly body. Acceleration due to gravity at depth, as it is depth, so D is written as symbol. Let's see the figure. Here A, B, C are the 3 points. A is at the surface, B is a point which is at the depth of D, and C is the center of the Earth. R is the radius of the Earth. And in this, if we calculate its value, the formula will be like this. This proof you learn in class 11 if you join science stream. Okay, so if you see here, GD equals to G1 minus D by R, and G will be G is the acceleration due to gravity of the surface, and its value is 9.8 average. Now let's test this formula for the surface and the center of the any object below the surface of the Earth. So let's assume the object is at A. In that case, point B is at A, and so D will be 0. From the above formula, D by R, 0 by R, that will be 0. 1 minus 0 results 1. And if you multiply 1 with 0, it will give you G, and so G equals to G. And second one, When the object is at center C, in that case B reaches to C, and in that case the D will be equal to R. And if you use that one, the above formula, D by R means R by R, that will be 1. So 1 minus 1, that will be 0, and the result will be 0. You know, you all are well known. D is smaller than R, or R is greater than D. So if you calculate D by R, its value will be less than 1 in third condition, when the object is in between A and C. That means that is in point B, below the surface of the earth. So as D by R is less than 1, results 1 minus that value gives you the result less than 1, and then GD will be less than G. Now mass and weight. This is not a new topic for you. We are learning about this from class 4, 5, 6. Okay, so if you see it, this is the physical balance, beam balance, tan balance, anything you can say. So mass, as you know, that is the amount of matter present in the body. It is a scalar quantity. It depends upon number of atoms and mass of each atom. Means if your size of the same substance is increasing, there are more number of atoms, so more mass of that object. Not only that, two objects having same volume have different masses because of mass of each atom of these two objects are different. It is a constant physical quantity because it does not depend from place to place. Its size won't change, nothing changes, so it won't change. Its SI unit is kg and CGS unit is gram. It is measured by a physical balance. Here are two pens, so force exerted on one pen, that is gravity exerted on one pen, is balanced by the gravity exerted on another pen, and they cancel each other, and because of that, it measures just simply mass. It is denoted by small m. The next figure you are observing here, that is a spring balance. Spring balance, it is because of it is acted by gravity, so it measures weight. The force of gravity acting on an object, that is called weight. Weight, the vector quantity, because it always directed towards the center of heavenly body, because acceleration due to gravity acting on acceleration due to gravity always directed towards the center of heavenly body. It depends upon mass of an object and acceleration due to gravity of the place. It is a variable physical quantity. As you know, the value of acceleration due to gravity is different in the different places of the earth or any other heavenly bodies. As acceleration due to gravity depends, so the product of mass and acceleration due to gravity will be different, and weight differs from place to place. It is a variable physical quantity as I discussed. Its SI unit is Newton and CGS unit is time. It is measured by spring balance, denoted by W. Now free fall. Clear from the word fall, free fall. Fall freely, falling freely. Here an astronaut falling freely is shown in the figure. The fall of an object due to gravity in the absence of any reactional force. Any reactional force may be a resistance to is called free fall. The acceleration of the freely falling object is equal to the value of acceleration due to gravity of the place because it is not acted by any reactional force. As the earth is surrounded by atmosphere, true free fall is not possible on the earth because every object experiences, though that can be negligible, but it experiences some types of reactional force. So true free fall is not possible on that. But as we all are well known, there is no atmosphere on the surface of the moon, and so true free fall occurs on the moon. When a feather and a coin are dropped simultaneously on the moon, they reach to the surface at the same time. A spacecraft requires centripetal force to revolve around the Earth in a circular path or elliptical path, which is balanced by the gravity of the Earth. The astronauts in the spacecraft are in the condition of free fall during revolution of the Earth. During revolution of the Earth, because it is in the condition of free fall. Now, weightlessness, weightless, no weight. Weightlessness or weight is shown in any measuring device because of the normal reaction force acting on that object. No reaction force, no weight. So when an object is in the condition of free fall, there is no reactional force, and no reactional force, so object does not show uh, any weight in the spring balance. The condition at which the weight of an object becomes zero is called weightlessness. The weight of an object is zero during free fall. The condition for weightlessness are as follows. During free fall, as we have already discussed, at the center of the Earth, acceleration, value of acceleration due to gravity is zero. So at G0, the product of M is zero, that will result zero during the revolution of the Earth in the spacecraft. Difference between free fall and weightlessness. Uh, Weightlessness is caused due to free fall. So weightlessness is the free fall is the cause of weightlessness, and weightlessness is the effect of free fall. And this is all about the theoretical portions of this chapter. Now we have some assignments as you used to do. Previously we have done. So now this is the assignment day third. And this assignment we have to submit as usual in the site. Class 10 science. Class 10 science at the rate, class 10 dot science. Class 10 dot science at the rate of las.edu.mp. You can send to it. There are some this time some always reasonable questions too. So you do it, submit it on time, and be ready for next class too. That will be next week. And be safe, be healthy, and keep it up. Thank you, and have a great day ahead.